Today we're going to be exploring rate of change on a graph, okay? Rate of change represents the slope of a line, okay? And we calculate it by looking at the ratio of the change in the dependent variable, which is the rise. Okay, which one's a dependent variable, x or y?
X.
Y. Y is the rise. How the line rises. What does it rise by? With respect to the change in the independent variable, which is the run, which is the x value, the change in the x values. Okay, so rate of change equals rise divided by run. And that was what you were looking at yesterday in your assignment. Rise over run. So you can always draw a triangle. We're going to count here, girls, is we're going to assume that this has a scale of 1. So it's counting by ones. If it didn't have a scale of 1, then we can't just count by ones. I'm going to show you an example of that in a minute. So this has a scale of 1 for the x and the y-axis is counting by ones. 3, 4, 5, 6. So we're just going to simply count the squares. You have the 2 points, we draw the triangle, and then we count. What does this rise by? How many squares? 1, 2,
3, 4, 5.
3. Look on your paper. Does it count by 3 squares?
Yes.
So the slope equals rise, copy this down on the side please, rise over run. The rise is 3, it goes up by 3. How many squares does it go across? 1, 2, 3. Who said 3? 4. Count again. It goes up by 3 and to the right by 4. So the slope of this line is 3 over 4. What's 3 divided by 4? On your assignment, you had to turn that into a decimal. 3 divided by 4 equals?
0.75.
Okay, so the slope of this line, the rate of change is 0.5 or 3 over 4. Okay, so for each graph, we are going to draw the rate triangle between the indicated points. Well, let's start by drawing a triangle. So like this and like that. And we're going to use this triangle to find the rate of change. Rate of change is the same thing as finding the slope. The slope is the rate of change, okay? Shh. How do you find rate of change? Rise over
Oh, I did it the wrong way.
run. Now, some of you probably started counting by ones. That is incorrect. I can't just go like this. Look here, please. I can't just go... Actually, I can for the rise, okay? Because there's a jump of 1. The scale is 1, so yes. For the rise, we can count by 1. So let's count. 1. Okay, here you guys. 2, 3, 4, 5, 6, 7. Did everyone get a rise of 7?
Yeah.
Now, for the run, pay attention. The run. Look here, please. Look at your scale. Did they skip 1 space? Look here. Yes. They did not skip 1 space and call it 1. They skipped 2 spaces and called it 1. So I have to skip 2 spaces, and that's 1. And then another 2 spaces is what? So what is the run? Is it 2 or is it 4? 2. Because from here to here, look here. From here to here, if you look at the scale, from 1 to 3 is a difference of what? What's 3 take away 1? 2. So the slope is actually 7 over 2. It's not 7 over 4. It's 7 over 2 because you got to look at the scale. Look here. Let's draw a triangle. You can draw your triangle here, or, Danica, you can draw your triangle here. It doesn't matter. As long as you're counting, the rise is vertical, the run is horizontal. You can do the triangle any way. I'm going to do it like this. Rise is vertical, run is horizontal. This is vertical, this is horizontal. Rise over run. What's the rise?
6.
Is the scale counting by ones? You guys made sure?
Yeah.
Okay, and the run?
3.
Good. 1, 2, 3. The slope is 6 over 3, which is equal to 2. Okay, so sketch a graph that shows positive. Well, I just went over this. What does a positive line look like? Like this? Is that positive? Okay, so this would be positive. And what would a negative graph look like?
This.
Okay, good. We're plotting 2 points. We're going to call them A and B. We always start at 0 for the where the x and y axes intersect. Then to the right is positive. 1, 2, 3, 4, 5, 6. Left is negative. Okay, so if you want to label your grid. Up is positive. And below 0 is negative. Make sure you are labeling it correctly. So we always graph x and then y. So x is 3. We start at 0, move to the right 3, and then are we going up or down 6? Good, up to 6. That should be your first point. And then we have b, negative 2. So we go across to the left, negative 2, and then up or down 3. So this should be the second point. I want you to connect the points.
It's just a line.
Okay, so now we're going to calculate the rate of change. You have 2 points. Shh. Draw your triangle. Draw a rate triangle like that. Are you looking? Do you see the triangle I just drew,
Yeah.
Ricky? Okay, so so slope
What if you got another way to
equals rise over run. We need to count the rise. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over, what's the run? 5. That's it. The slope is 9 over 5. Is it positive or negative?
Negative.
Is it positive
Positive.
or negative 9 over 5?
Positive.
It's positive. Any line that rises to the right, so any line that's drawn in this direction, rising to the right, any single line that looks like that will have a positive slope. Okay? What do you think a line with a negative slope? Think about trends. We talked about this. Rising to the right is positive. What do you think a negative line, a negative slope would look like?
going down?
Going down to the right. So something, I'm going to draw them in purple. Okay? So something like this. Going down to the right. These would be negative. These are negative lines, which means they will have a negative slope. Okay, so here we're at the same page. We're trying to find the rate of change, but this time you're given a table. Well, we know that the rise is vertical, which means it's the change in the y values. Up and down is y, right? The run, so this would be rise. The run is the change in the x values. So in our table, this would be x and this would be y because the profit depends on how many weeks the company is open, okay? X is always the independent and y is the dependent variable. So we need to figure out what is the rise over the run. Pardon? Okay, so we need to calculate the difference. What does this rise by? What does profit rise by? 1,500. Does it rise by 1,500 again?
Yes.
And again?
Yes.
And again?
Yes.
Okay, what do the number of weeks increase by?
1.
Oops. Is this going to be linear, Marcus? Yes, how do we know it's going to be linear? It increases by the same amount. The differences are constant. Remember I told you that word? You're going to hear that word a lot. Okay, so the rise would be what? 1,500 or 1? What's the rise? 1,500. And what do the x values increase by? 1. That's it. That's the answer.